Hello and welcome to this lesson, which is all about working with arrays. In this lesson we are going to learn how we can arrange all the names of our levels into an array, and then we're going to start creating pure and impure functions that we can use to retrieve information out of the array, which we can then use for loading new levels once a level has been completed. Okay, so we're going to be making use of what we've learned in the previous two lessons by working with pure and impure functions, and also by working with arrays in this lesson. Inside our win level volume, we're going to start by creating a new function called complete level. And in our event graph, we can remove the print strings that we created in the previous lesson, and we can remove this variable that I left over from the previous lesson as well. We're going to drag out the complete level function onto our graph, and we're going to hook it up to the false output of the branch. When no crystals are remaining, we're going to execute this complete level function. And this function is going to handle loading new levels for us. And to help us do this, we're going to create an array that is going to contain the names and order of all the levels in our game. To create an array, we're first going to create a new variable, and we're going to call this level names, and we're going to change the variable type from a boolean to a name. Now when we hit compile, we can see on the default values that we can assign a value to the name here. We want to provide numerous level names, so we want this to be an array. To change this variable to an array, just where we selected name, we can see this line symbol just next to it, and we can click this and select the dotted square here, which represents an array. And now this is an array. It still looks the same here, but if we hit compile, it now updates the default values to an array. It's telling us that there's 0 array elements, but we can add array elements by hitting this plus icon just next to it. And this is where we can provide numerous values now to this variable. And this trash can icon just next to it removes all the array elements. So we have only got one level now, but let's just imagine for the time being that our level name array has 2 elements. The array here is going to contain the names of all our levels, and the order of the array is going to represent the order in which our levels will be completed and loaded. When we complete level 1, it's going to load level 2, and so on. So let's take a look at setting up this array to represent the first 2 levels of our game. We can add 2 elements to it by hitting the plus icon twice. And the first element here is going to be the name of my first level, which is the current level I'm in. And we can see the name of the current level just by looking in the viewport, and we can see it in the bottom right corner of the viewport. So it's level 1 for me. So the first level for me is level 1. And I want the second level to be level 2, but I don't have a level 2 currently. So for right now, I'm just going to do a file save current as to save the second level as level 2. And now we have 2 levels for our array here. So this is all I'm going to do with the array. We can come inside the complete level function to start implementing some code for it. Now what do we want to do with this complete level function? Well, when it executes, we want the engine to load the next level, but we need to be careful here because we need to ask some questions first. We need to know if the current level is the final level in our game. And to be able to ask this, we need to know the index of the current level in our level names array. And with this, we can also ask what is the next level to load. So we're going to start mapping out these questions as pure functions. Now let's start by creating a pure const function for getting the index of the current level. Inside this function, we want to get the current level name. Then with our level name array, we are going to call the find function to try find the current level name in our array. And the find function returns an integer. It will return the index of the current level. And we will use this index as a return value on our pure const function. So your challenge right now is to have a go at setting this up. Create a pure const function called getCurrentLevelIndex. Then inside this function, call the find function on the level name array to find the index of the current level name. Then make the pure const function return this index. So I encourage you to pause here to have a go at this challenge, and then in a few moments we can walk through this together. Okay, so let's add in a new function called get current level index. And we want to make this function a pure const function. So we'll check the boxes for pure and for const. Now with this function, we want to get the current level name. And we're going to hook this up with the execution pin here. And then with our array, we can call the find function, or the find item function here. And we can chuck our current level name into the input for this, and it converts it from a string to a name. So it's going to look through our level names array and try find our current level name there, and it will return the index of it. And we want this to be returned on our function. So to do this, we can select the entry node or select the function on the My Blueprint tab, and we can add in a new output called return value, and we can drop down from Boolean here and change it to an integer. And let's just hook up the execution pin to this and make sure the find output is connected to the return value. And now we can hit compile, and we can come back to the complete level function, and we can now drag out our newly created pure const function called get current level index. So let's just visualize briefly what this is really doing. Imagine we have 4 levels in our game, and we have all the names of them in an array. To get the current level index, we provide a name, and then the engine searches through our array and matches the array element with the same value that we provide. So here, if our current level name is level 3, the find function searches through our array and tries to find a match with an array element that has a value equal to level 3. But remember, our function returns the index of this array element, so the index it will return here will be 2. Okay, so we can get the index of the current level name. Now how does this help us here? Well, let's look back at our questions. We can now ask how to get the current level index from the level array, which now allows us to ask the first question, which is the current level the final level for our game? Let's grab our level names array, and let's call a function on it by coming to utilities and then array, and let's grab the last index function. This gives us the index of the final level in our game. We can drag this out, and we can use the equal symbol to grab an equal integer, and we can compare this to the index of the current level. So this code here now asks the question, is the current level the final level? And it returns a true or false result for that. We can select all of this, and we can right click and collapse this to a function called isFinalLevel. Now we want to make this a pure const function, and we want to add an output for this named return value, and we can make this a Boolean. And if we just double click on the function to enter it, we want to make sure that our code sits nicely into this and then returns our Boolean value here. So now when complete level is executed, we can ask if we are playing the final level in the game, and we can use a branch with this and connect the return value to the condition here. Now if it isn't the final level in the game, we want to load the next level. So our next question is going to be, what is the next level to load? And I want you to have a go at this one. Create an impure function called loadNextLevel. Inside this function, get the index of the current level. And remember, we already created a function for this, so you won't have to write any code to do this. So call the function we created, but increase the index by adding the value of 1 to the result. This will give us the index of the next level in the array. And then the final step here is to get an element from your level names array by calling the getArray function. And then we can use the index we just calculated to get the next level. So pause here for this final challenge, and then when you're ready, we can wrap up this lesson. Okay, so let's create a new function called load next level. And inside our complete level function, we can call the load next level function from the false output of the branch. So when complete level is executed from the event graph here, we check to see if we are on the final level of the game, and if we're not on the final level of the game, that means that there's more levels to play. So we then execute the load next level function. Now we want to get to the index of the current level. We've already created a function for this, so we can drag it from the function tab here onto the graph. Now this returns the index of the current level, but we want to add 1 to this to get the index of the next level. So we can drag out the return value, we can put in a plus symbol to get an integer plus integer node, and this is now the index of the next level in the array. So if we grab our level names array and use a get, and if we drag out the array pin and just type in get into the search bar, we can get 2 array functions here. We can get it by using an index, which is the a copy version here, or we can get it by using a reference. We're going to use the get a copy version just here. So we can plug the return value of our plus node here into this, and this is basically saying look at our level name array and gets the current level index and add 1 to it to get the next level name out of the array. Now what can we do with this? Well, we can call the open level function, and we can use the result of our little calculation here as the level name to open. Okay, we can hook up the execution pin here. So we can clean up our code even further here just by selecting all these nodes, and we can right click on them and collapse them down to a function, and this can be called get next level name, and this can be a pure const function. And if we want to change the output pin name, we can change it to something like return a value. Now let's come back to our event graph and let's view our blueprint from the top level. I'm also going to close all my tabs here so I just have the event graph. So looking at our blueprint from the top level, when something overlaps with our trigger volume here, we check to see if it's the player. And if it is the player, we check to see if there's any crystals remaining in our level. If there are crystals remaining in our level, we don't do anything. This means that the player hasn't collected all the crystals. So once the player does collect all the crystals and overlaps with this volume again, this would mean that the false output would fire. So when no crystals remain, we execute this complete level function. And this function checks to see if we are on the final level of our game. And if we're not, we load the next level. However, if we are on the final level of the game, what do we want to do? Well, this is totally up to you. We could reopen the first level of the game by getting the first element of our level names array, and we could just open that level. And at that point, our game would loop once you complete the final level of the game. Or we could just call the quit game function to exit the game once all the levels have been completed. So it's totally up to you, and make sure to post your results on the Game Dev TV community forum. But in my game, once the player has completed all the levels, I'm just going to call quit game. So before we end this lesson, we want to just organize our functions here. I'm going to select the complete level function, and I'm going to put it in a category called level management. And when we hit enter here, we can see on the My Blueprint tab where we have the function section, our complete level is now in this level management category. And we can take these other functions that we've created that relate to level management, and we can click and drag and drop them into this level management category just to keep them organized. And now when we hit compile, we can right click in the graph to bring up the action menu, and if we scroll down, we can find our level management category with our functions inside of it. Okay, great. So now remember, when you create and save new levels for your games, you can add the names of your levels to this level names array that exists in this actor, and you can add them in the order you want the levels to be played. So when the player completes levels, the player can then move on to a new level. Okay, so that wraps up this lesson. We're now ready to start wrapping up our game by creating some levels with all the assets we've created. And we can also review our code before packaging the game. But before moving on to the next lesson, I'm just going to leave you with these slides here that show the functions and the codes we've implemented for them in this lesson. But once you're ready, I'll see you in the next lesson. Hey, and well done for making it this far. In this lesson, we're going to be finishing up Crystal Cavern by taking a look at casting, and we're also going to be fixing some issues with the physics of the player. And we're also going to spend some time designing some levels. Okay, so in our project, we now have a bunch of actors that we have created all throughout this section. There's so many more actors we could build to continue extending our game, but that's going to be a long-lasting challenge to you as a student of this course. What other actors can you build with what you've learnt from this section? Make sure to post and showcase your work on the Game Dev TV community forum so us, instructors, and other students can see your results. Now I currently only have 2 levels in my game, but I really only have one because my second level is just a duplicate of my first level. My first level is really not designed out yet either, so in a moment I'm going to spend some time designing my first level better, and then I'm also going to design a completely different second level, and I want you to do the same if you haven't done so already. Design at least 2 levels by making use of the BSP geometry tools, and make use of all the blueprint actors we have built in this section to build out your levels. I encourage you to have a go at this challenge and then continue the lesson to see how I have designed my levels, as I'm going to do something quite interesting in my second level. So pause here and make use of all the actors and the BSP tools we've been using in this section to create some levels, and then when you're ready, come back and resume the lesson. Okay, so here is my updated level 1. I've changed the materials of the BSP geometry in my level, and I've also tweaked the lighting. With the player pawn class, I've applied a material to the mesh, and I've increased the acceleration multiplier to give the player some more control, and it also feels a little more fast-paced while playing. In my bridge path areas here, I've added a spotlight above with a very soft intensity just to help the player see a little better. I still have my cannons in the level that the player has to avoid, but later on in my level, I've added some pipes that I've just made with additive and subtractive cylinder BSP brushes. At the end of my level here, I've placed a wind volume inside this final pipe. But we need to remember that the player has to collect all the crystals before moving on to the next level. So something to keep in mind is to allow the player to return to previous areas to collect any crystals they may have missed. Once the player has collected all the crystals and enters this pipe in my level, it loads the next level. Now here's the interesting thing here. In my second level, it looks like it's completely changed perspective a bit. And it has, because when this level loads, the player's spring arm has adjusted its pitch and its distance to give us this different perspective. So I'm going to show you how I've done this now, just as an option for you, as it's pretty easy to do. Inside my player pawn, I'm going to create a new function called adjust spring arm. And I'm going to add 2 inputs into this function, and they're going to be a float input type. The first parameter name is going to be distance, and the second parameter name is going to be pitch. We're going to use the distance input parameter to change the target arm length of the spring arm, and we're going to use the pitch input parameter to set the world rotation of the spring arm. So to do this, we can grab these spring arm components from the components list, and we can click and drag it onto the graph. To change the spring arm's distance, we can call set target arm length. And we can simply plug our distance input parameter straight into this. And let's make sure to hook up the execution pin here. Now for the pitch, to change the pitch of the spring arm, we want to change the world rotation of the spring arm. So we're going to drag out the spring arm reference again, and then just call the set world rotation function. So this takes in a rotator. We can use a make rotator to gain access to the roll, pitch, and yaw values here, or we can just right click on the pin to split it to gain access to the roll, pitch, and yaw. We can just plug the pitch straight into it. So this is all we need to do here for this adjust spring arm function. We can hit compile, and if we come back to the event graph, we can drag out the function just to take a look at what it looks like. So we just have some simple input parameters for the distance and the pitch to adjust the spring arm. And we don't want to call this inside the player pawn because we might have many different levels, and we don't want this to be applied to every level. And currently I'm only changing my camera's properties or adjusting the spring arm on level 2. So this is where we can bring in the level blueprint again. We can do something very specific in level 2 by using the level blueprint. On begin play in level 2, we can get to the player pawn and we can call our new function that we just created. Now let's take a look at what happens here when we drag out the return value and try to call our adjust spring arm function. We can see that we have no results for the function even though we just created it. This is because the return value doesn't actually return our custom BP player pawn blueprint class that we created at the start of this section. Let's break this down quickly. In Unreal Engine 4, when you create a pawn class, you are inheriting from Unreal's parent pawn class. You are taking Unreal's parent pawn and you are extending the class by creating a child of it. So this return value on the getPlayerPawn function is actually returning Unreal's parent pawn class, not our custom class, which is why we cannot access our function. But we can do this by casting. Casting allows us to access the properties and functions of the class that we cast to. So when I drag out the return value here and type in cast, I'm trying to ask what type of pawn class am I working with here. So if I choose cast to BP player pawn and hook this up to the begin play, we're saying get the player pawn, is it the BP player pawn blueprint class? If it is, this output here will execute, the one with no name. This is the true output, so this will fire. If it's not the player pawn, so for example in our game mode if we were set to the default pawn, the cast failed would fire here. And then we have this as BP player pawn reference pin here. So this is a reference to our player pawn class. If we drag this out, we can now call our adjust spring arm function. And we can change the distance here. So I'm going to change the distance of the spring arm to about 850 units, and then the pitch can be negative 15 units here as well. So when we start the game, or start level 2, mind you, when we start level 2, we get to the player pawn, we check to see if it's the BP player pawn class, and if it is, we adjust the spring arm with these new values. So now if we come back to our level and hit play, we can see that the perspective has changed and it's only applied to this level because this code is only executed in the level blueprint of level 2. Okay, so before wrapping up this section and packaging our project, there's one more issue I've noticed that we should tackle. I've noticed that the player pawn sometimes spins endlessly when moving around the level, and this is because there is no damping applied to the mesh of our player pawn. Damping only affects components that are simulating physics, and we can think of damping as a resistance against moving or rotating. There's two different types of damping. There is linear damping, and we can think of this as how much resistance against movements we want to apply. And then there's angular damping, and we can think of this as a resistance to rotation. So a quick challenge for you right now is to apply damping to your player pawn's mesh component to prevent this endless spinning from happening. So pause here and go take a look at your player pawn's mesh component, and then we can move on to packaging our project. So to prevent this endless spinning, we can come to our player pawn blueprint, we can select our mesh component, and where we check simulate physics, just under this, we see the linear damping and the angular damping values here. Now we want to prevent the endless spinning, so we're thinking in the terms of rotation here. So let's just apply a higher value to this angular damping. I'm just going to use the value of 0.8. But you need to be aware that this is like a drag that's going to be applied against your mesh to slow your rotation down. So make sure to tweak this while tweaking your acceleration multiplier in your player pawn. But this will prevent the endless spinning that we see. So just keep tweaking those values there. Okay, awesome. So we've covered quite a lot in this section. We've covered how to create blueprint actors and pawns. We've covered how to create blueprint variables and also how to expose them. We've learnt about controllers and possession, how to apply damage to actors, and how to create timelines and timeline tracks. And we've learnt the difference between pure const, and impure functions, and we've also learnt how to create macros and macro libraries. And we've done a lot more too, and I really hope you've enjoyed this section and that you feel like you're starting to harness the power of blueprints. And again, I encourage you to post and showcase your work from this section to the Game Dev TV community forum. And if you have any questions, please post there too, as myself or other students can reply and help out. So I'm going to leave you with this final challenge for this section, and it's all down to you. I want you to package your game. Only include the maps you are using in your game, and we've covered this in section 1. You're going to be looking inside your project settings to do this. And this time, try packaging a shipping build. So well done for making it this far, and just keep at it, keep blueprinting, and see what else you can do to extend Crystal Cavern.